Okay, guys, here we go. Day 3, conditional probability. We're not going to do this challenge, so you can get rid of that. Let's jump right into all of this. Hopefully you were able to print the notes, or you're just going to copy and pause as we go. Okay, so if we were in class today, I was going to do a little, just a quick activity with you. So we'll still just do it because I have my roster, so I'll just go off of memory for this one. So it says, if a student is selected at random from our class, that should say from, find the following probabilities. A student with blonde hair is selected. All right, so I'm going to use period 2. So period 2, I have 25 people, so that's my sample space. And then how many have blonde hair? All right, so I picked Danielle, Anna, Cameron, and Megan. So 4 out of 25 have blonde hair. But now I'm going to change the probability. Instead, I'm going to say, if one student is selected from our class, find the following probability. A student with blonde hair is selected given that they're a girl. This changes my sample space. This puts a special condition on it. This means I only can pick from girls and now see who has blonde hair. So my sample space changes. So if I go back through, though, those were all 4 girls. So the probability would be 4 out of 4, so it would be 100. So a conditional probability, it's just putting a condition on something. You're going to search for blonde hair, but they only could be girls. Kind of like when your parents are like, all right, you can go out, but you got to be back by 11. So the condition has to take place before you're allowed to do it. Now we have a formula that we use. So it's the probability of A given B. That's what this means right here. And we replace that with the probability of A and B divided by the probability of B. And I'll make that very easy for you as we do the questions, but you'll see this is on that formula sheet, but I'll show you how to use it in this one here. All right, we'll start out with a basic one first. So we have a two-way frequency table. We're comparing gender with whether people are going to college or not. If a person from the survey was picked at random, find the probability that the person was a female going to college. Okay, so here I'm picking from everybody. There's 52, and I'm just looking for female going to college. So female going to college is right here. Female going to college. So 13 out of 52. So that's just a regular probability like we've been doing the previous 2 days. But now here's the one that's going to change. It'll be like whatever it's going to teach you today, the conditional probability. If a person from the survey was picked at random, find the probability that the person was female given the person was not going to college. So here's my conditional now. So I don't want to look at everybody. I'm only looking at the people that are not going to college. So we're going to set it up using the formula. So probability of female given not going to college. And then I'm going to change it. I'm going to change it to be the probability of female and not going to college divided by the probability of not going to college. And this is what that formula was on the front sheet. I just like to write it going vertically. So I'm just going to highlight and discuss it one more time. So this right here, we were finding the probability that they were female given the person was not going to college. That's what this is. Probability of female given not going to college. You change it, you take the given sign, and you change it to an and. And then you divide through by whatever that second piece is. So you just have to memorize the formula. Okay, so now let's replace in. Let's find the probability of, oh, that's too thick. Oh, goodness. Okay, so let's find the probability of female and not going to college. So there's 52 altogether. Female and not going to college is 9. And now the probability of not going to college, well, there's 52. How many people are not going to college? 23. And I'm sure there's a whole bunch of you out there being like, oh, top, bottom, right? So keep the top, multiply by the reciprocal of the bottom. We're allowed to reduce right here in a bow tie, right? And we're left with 9/23. Now, I really encourage you to use this formula. Sometimes there's shortcuts that can be done, absolutely, and I'm sure some of you see them in this question, but you have to trust me that you are going to have to use this formula. So I really wouldn't go for the shortcuts in the table. You should just really 100% trust me, because I want you to be able to get these questions right all the time, not just some of the time. Okay, and you know I say that all the time. Okay, next one. So let's write this one. If a person from the survey was picked at random, find the probability that the person was going to college given, there it is, there's the condition, that the person was male. Okay, so let's write it out. Probability, college, given, male. So now we change it over using the formula. Probability of college and male. Just take that little conditional symbol out and make it an and instead. And then divide through by that second piece. I wish I was in front of you to do this, because there's so much visually I would be doing, but I'll just try with the highlighter. So you always replace this with the word and then this is always what you divide by. Okay, let's do the math. Okay, so probability of college and male. So there's 52 altogether. Right? Now we got to go back up. College and male. So college and male. I'll erase some of those guys. Okay, so college and male. Oh, I gotta use these thingies, sorry. 16. Okay, and then we'll go back down here. Right, we got 16. And now the next one, probability of male. So 52 again all together. And then we'll go back up and see how many males. So how many males do we have? 30. So I don't know, it's kind of fun. I like it because it's the same, it's the same formula every time. Just plug it in, and every time it turns into top bottom. So keep the top, multiply by the reciprocal of the bottom, right? That's how we simplify complex fractions. These guys wipe out, and that's a nice little safety check for yourself as well. And we're left with 16/30. You don't have to reduce in the probability unit. You can leave it like this if you like. All right, so we're just going to do a few. So let's try another one. We'll do one with a Venn diagram now. In the Venn diagram, shown to the right, each dot that's my cat sneezing. Each dot represents an equally likely outcome of the sample space. Some of these fall into event A, some fall into event B, some in both events, and some in neither. Okay, find the probability of A occurring given, there it is, that B has occurred. So let's write that out. Probability A given B. Now change it over. The formula tells me to replace the given symbol with the word and is intersection, that's both, divided by probability of whatever that second piece is. Okay, so let's do it. Probability of A and B. So A and B, that's my cat again, probability of A and B. So that's going to be both. So isn't this section in here, right? That's the both section, both things happening. So that's going to be 2 out of, now you got to add up every single dot. So if we add up every dot, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, divided by the probability of B. Now B is this whole circle. So how many are in there? I think we got 5 altogether, right? So 5 out of the whole thing, again, 12. And then here it is, top, bottom again, simplify your complex fraction. And you'll see this will happen every time for you. And we're left with 2/5. Okay, hopefully you like this. The conditional probability. So here's a Regents question for us to try now. Okay, first thing that stands out to me is that the totals are not there. Do you see that? So we got to add up. So I'll add up going this way, right? And I get 35. I'll add up all these. I get 109. You can go ahead and do that as well and pause it if you like. I get 312. Then I'll add up going this way, right, all the way. I'll get 109, 118, 229. And then if you add up all these going this way and all of those going that way, you better get the same number. That's the total. Remember, we're going to need that number. That'll be the number that's the same in my top bottom. Let me just get rid of my markings. Okay, so I like to have this number. Oopsie, yikes. I like to have this number accessible. That's my total. All right, let's check it out. The set of data in the table below shows the results of a survey on the number of messages that people of different ages text on their cell phone each month. Okay, so we're comparing how old you are, right, with the amount of text messages you send a month. If a person from the survey is selected at random, what is the probability that the person, I'm just going to underline some of this, the person texts over 50 messages per month, and here's our special word, given that the person is between the ages of 23 and 60. All right, that's like so much to like write down. So we have to kind of abbreviate it a little bit. So let's see. I'll do the best I can here. So probability of, it's hard to abbreviate too much, right? Over 50 given 23 to 60. I don't know, I guess that's the best I'm going to do. And then I'm going to change the word, change it to and. So over 50 and 23 to 60. And then remember, what are we dividing by? We're dividing by that second piece, probability of 23 to 60. Okay, so let me make more room. Okay, so probability of over 50 and 23 to 60. All right, so we have 456 altogether. I'm going to come over here. And so we're looking for and intersection. So over 50 and 23 to 60. So over 50 and 23 to 60. Do you see how that's this one here? Over 50 and 23 to 60. So that's the intersection of the two. So 157 over 456. All right, then big fraction bar. And then I'm looking for 23 to 60. So 456 is still my bottom. And then how many are 23 to 60? I think I'll just use the highlighter now. So 23 to 60, right? I need the total. So that's 229. Here's my top bottom again. 157 over 456 times 456 over 229. And it's nice because that goes away every time. And there's my answer, choice 1. Okay, so great Regents questions for you guys to be able to do. So maybe pause it, rewind it, do it again. Okay, really good question. All right, we're going to skip 4. We don't need to do everything. Okay, number 5. So I started to fill out a little bit, make this go a little quicker. So it says when a student is selected at random from a large population of high school students, the probability that the student has a smartphone is 0.68. And you can see all I did was fill everything on the side. Oh, goodness gracious. Come on. Sorry, I gotta make these pens work. Okay. Is it working? Yes. Okay, so I just wrote it on the side. And the probability that they have a tablet, 0.36. And the probability that they have both of them, right, and is 0.09. Now they're saying let A be the event that the student has a smartphone. So now you could change this over to A. Let B be the tablet. Okay, so I'm sure you'd like to start out with using the letters, but you can switch over since they said to do this and see what they're saying. They want you to calculate probability of A given B, so you should change those over. All right, so probability of A given B, change it over, probability of A and B. What do we divide by? The probability of B. And now here we won't have top bottom because somebody took a fraction and turned them into decimals. And then we'll see that the answers are percentages. All right, probability of A and B, we're just plugging it in, 0.09. Somebody already made it a decimal. Probability of B, 0.36. Use your calculator to divide. You get 0.25, and then you can see that somebody turned it into a percentage. So let's not forget our decimal to percent. So we're right here. So we're going 2 places to the right, so 25%. Good stuff. I hope you like it because it's just using the same formula over and over. But it's such a popular question. All right, let's look at this one. This is a good one. This is one not everybody always gets. It says, given that the probability of B given A. Now, who cares what letters they use, right? Oops, here we go again. It doesn't matter what letters they choose to use. Okay, they're doing B given A. Means that means the probability of event B occurring given that event A will occur or has occurred, which of the following correctly calculates this probability? So you're supposed to take this and just do what we've been doing the whole video here. Probability of B given A. Change it. Probability of B and A. And what are you supposed to divide through by? The second piece, probability of A. Right? We're always dividing through by this. So do we see which choice it comes out to be? Choice 4. Looking good. Okay, 7. I took some of the information out to try and be able to move through this a little faster for you. Okay, the guidance department has reported that of the senior class, 2.3% are members of the Key Club. And you can see that I took a percentage, right? Decimal to percent, and I changed it into a decimal. 8.6% are in physics and 1.9% are in both. Determine the probability of P given K to the nearest tenth of a percent. So probability of P given K. Here's our formula again. Replace that given with the word and. Divide through by the probability of the second piece. And now just replace in. So probability of and. So also notice that I wrote here probability of K and P, and here P and K. But and doesn't matter. Order doesn't matter for and. But for the conditional, the order matters. Okay, so we have 0.019. Just substitute in. 0.023. Divide. And again, use your decimal to percent. So 2 places to the right. And now they want nearest tenth of a percent. So here's my tenths place. If I look 1 place to the right, it's 5 or greater, 82.6%. Alrighty. Okay, 8. This was another Regents question. Little tiny bit of trickiness happened in the very, very beginning. It says, a study was designed to test the effectiveness of a new drug. Half of the volunteers received the drug. The other half received a sugar pill. So a lot of times when new medicine comes out, they make up 2 groups. One group, well, everybody gets a pill, but one of the groups gets the real pill, and the other group thinks they're getting the real pill, but it's called a sugar pill. And this way they can see, are there really any results or not, even though everybody thinks they're getting the pill. Okay, so what's tricky about it is, so you need to realize that probability of getting the drug is half, so it's 50%. So you have to turn that into 0.5. And then the probability of the sugar pill, half of them got that too. So that's 50%, so that's 0.5. They're saying it in words, not numbers there. And then the probability, find the probability of a volunteer receiving the drug and getting well was 40%, so turn that over into a decimal. And then they want us to find the probability of getting well given, there's my word, that the volunteer received the drug. So probability, whoa, that got crazy there. So find the probability of getting well given that they got the drug. Change it over, probability got well and the drug, and what do we divide it by? The probability of the drug. Okay, so let's sub in. So probability of getting well and the drug, so that's just 0.4. And here it is again, the order doesn't matter with and. So 0.4 divided by 0.5. We get 0.8, but we got to read carefully. What did they ask for here? Oh, okay, I guess they didn't specify, right? They didn't ask for a percentage. What is the probability of a volunteer getting well? Yeah. Okay, so you can leave it as 0.8, or you can tell me 80%. It doesn't matter because they didn't specify how to put your answer. All right, good stuff. I really like these. All right, last question. I'd like you to do number 9 for me. So go ahead and pause. You guys do number 9. Oops. Okay, so here it is. Hopefully you got it right. All right, so we're going to stop right there. Homework is the next page in the packet there. It says day 3 homework, page 19 and 20, but I guess you don't really have page numbers, but you can see it's this right here, day 3 homework. Okay, so you guys will just work on that for me, and all the answers are there. But on the materials section, you can print this without all the answers on it, and you guys can do it and then use this to check and make sure you're right. All right, have a great day, guys. Bye.